Hello, welcome to Picture Recoding with Eric Gaker and Mike Mull. Hi, Mike.
Hey there.
Mike, I discovered an album this week that I started listening to, and it was one of those like, oh, I missed this when it came out. Have you ever listened to Joshua Redman, the saxophonist?
I have quite a few times through the years. I think I discovered him way back when he was sort of like playing with Wynton Marsalis.
Mm-hmm.
Um, but yeah, I've listened to him on and off throughout the years.
So he's got a new record coming out this month, and I'm looking forward to it because some of the stuff I've heard off of it, it sounds cool. But he came out with a record in 2020 I didn't know about with Brad Mehldau. I really like Brad Meldau's playing too. He plays piano. And this one's pretty good. It's called Round Again. He's a jazz saxophonist, as you know, and I really like his work. He has this breathy, surprising way of playing saxophone. Surprising for me. There's like a lot of pathos in it, and I'm always surprised by how it affects me when I hear him play. So I'm really looking forward to the new record coming out. But it was kind of cool to see this one that I hadn't heard before with Brad Meldau from 2020.
Yeah, I'm pretty sure I've listened to this one. I also am a big Meldau fan, piano jazz in general, but
Mm-hmm.
I like his takes on things like Radiohead songs and so
The
forth.
Radiohead, yeah. His Blackbird is absolutely phenomenal. One of the best ever.
Yeah.
Yeah, he's great. But Joshua Redmond, good too. And I'm excited about the new one that's going to come out later this month. What about you? What have you been listening to? More death metal?
Sort of, yeah. I've been listening a lot to this album by Alan Sparhawk, which, uh, just as an aside, is also a super cool name.
Yeah.
I think I might change my name to Sparhawk, but anyway, he is one of the members of the band Low, and
Oh,
uh, they'd been around for a while, and had made a couple of really critically acclaimed albums in recent years, and then his partner in Low just kind of surprisingly passed away a
oh,
couple of
I
years
didn't know
ago.
that. I didn't know that.
And so after she died, he made a couple of solo records. This is the second solo record, I think. But this one, the title of the album is apparently "With Trampled with Turtles," and it is also literally "With Trampled with Turtles." Um, so Trampled with Turtles is this folk band that I've listened to every once in a while throughout the years as well. And
I swear you've
um,
told me about them before. Haven't you told me about them before?
yeah, probably. I think I've directed a few people toward them. You know, they're the kind of band that if you like mandolins and banjos, you're probably gonna dig them. But anyway, this one is much more in the sort of folk rock genre than his other work with Low, especially. But I really enjoy it. It's got a bunch of good songs on it. Kind of a change of pace. I've been
Hmm.
looking for interesting sort of folk Americana stuff recently, and
Oh, okay.
there's been a few. It's been a few good things out, but this one has really stuck with me for some reason. I think it's probably got a little bit of a different take just because of where he's coming at it from. Highly recommend if you're into that sort of thing.
I'm into that sort of thing. I'll check it out. Although I never really liked Low. Is that a
I think they're a
correction?
bit of an acquired taste, yeah, but
I never acquired that taste.
I, I appreciate his attempts to do interesting things, if nothing else.
Hmm. Now, for this week, you had a pretty interesting suggestion, a pretty good suggestion for what we should cover. And you had a broader idea, I think, that I really liked. Can you tell us about it?
Yeah, so we had discussed a little bit of doing sort of a series of episodes on database technology. Partially, it's so foundational to what we do. And also, it's been undergoing a bit of I don't know, a transformation over the
Hmm.
last couple of decades. And so we kind of had this idea of like starting back at the beginning and talking about early database stuff and then
Hmm.
working our way through more modern versions.
What would
But
you say is a good analogy for databases for people like us who do the kind of work we do? Is it like lathes for carpenters? There's a lot of
I
different
don't,
ones. and you got to pick
Yeah, I don't
them,
know.
right?
It's not. So I think of a lathe as being like a tool,
Right.
and
You don't think of a
databases
database
are.
as a tool, not a tool.
This is probably a bad analogy given what we're going to talk about later, but
Mhm.
it's kind of like if you're a sailor, then the database is the boat. Um,
Okay, so you might have different
uh,
kind of things you want to do on your boat, or like if you're gonna race, they have those like off-road car races that they do in Europe, and then they have like I don't know races where you just drive around a big circle. Maybe that's the car is the database. I'm really stretching these metaphors here.
but I think it's used in different ways and it's meant in different ways. But I think it's sort of almost in most applications these days, it's kind of a fundamental component of what you're doing, and
Mm-hmm.
it's been so it's gotten a lot of attention over the years. It's an important thing in both like business applications and scientific world and pretty much everything that people do with computers, I guess,
Yeah, so you
except
pretty
for
much always have a database somewhere in your project, right?
yeah. I mean, there's stuff I guess where you're doing strictly computing, but for the most applications are going to have some variation of database.
What does that mean to you
Anyways,
to start at the beginning?
it's probably we're probably actually starting 10 or 15 years after the beginning,
Mm-hmm.
but I'm thinking about the sorts of things that were coming into existence when I was a rookie, back in the 1980s,
Mm-hmm.
and the research that had been done to develop those things. And I think for me at least, that is kind of what I started working with, and what was kind of what everybody thought of being a database in those early years was, the relational database. So
Mm-hmm.
it meant things like Oracle or DB2 or Ingress if you were, fancy, cutting edge.
Mm-hmm.
But one idea was we just, do an episode on relational database topics. But we have this series that we've done before where we talk about um, prominent people that we call it our standing on the shoulders of giants series, and we've
Mm-hmm.
done a number of prominent computer scientists and Turing Prize winners and so forth. And so
Mm-hmm.
to sort of combine the beginning of our talk about databases and also to do an episode in that Shoulders of Giants series, we decided to talk about Jim Gray.
Mm-hmm.
And Jim Gray is a Turing Prize winner, guy who did a lot of very foundational stuff in the database world, especially the relational database world. He also had kind of an interesting life
Yeah. Yeah.
that we will delve into as we go through this.
Yeah, he is interesting. Because his story of his life is interesting. The work he did, the research he did is interesting, and he worked in industry. And I find him almost a little bit more relatable than some of the researchers we've talked about. I mean, look at somebody like Les Lamport, and his take is often, well, this is just math. If you know math, this is easy. And I look at his work and I think, it doesn't look easy. I had a couple quotes about Jim Gray that I found in a Wired piece about his disappearance. This is from Google co founder Sergey Brin. He said, Jim's work inspired us and many other computer scientists to seek out and tackle very ambitious projects. He never shied away from problems involving large scale data and computation. So that's Sergey Brin. Uh, the one thing that I really liked is in an interview with him, they said that when conference hosts would try to introduce him as like a database guru or a god, he would just say in response, "No, I'm just a programmer."
I suppose we should probably mention that one of the interesting parts of his life was his sort of tragic end.
Yeah,
Um,
yeah.
since you mentioned his disappearance, so one thing we will get to is that he kind of disappeared, and we will talk about the details of that later. But
Hmm. Hmm.
in 2007, he went missing and was never seen again.
Yeah,
So
yeah. So that story is that the mystery and the like response that people had to it is also in itself just an interesting story. Okay, so you sent me a paper which is a summary of 8 papers Jim Gray had published along with other co-authors on databases. But instead of starting there, should we talk about, what do you want to start with? What should we talk about first?
Well, I thought we would just kind of go through his life in a sort of chronological sense, and so maybe we can start off talking about his Berkeley years.
Okay, go Bears. Let's do that.
So he got all three of his degrees at Cal, he started there in 1961. Read something about he was going to be a philosopher
Yeah,
at
yeah,
first. He
yeah.
had another.
I found this quote from him in this interview at Microsoft, and he said he got to Berkeley and he was studying. He was really interested in philosophy because he was interested in epistemology and how we understand things. He said, but he said the problem is they were using modus ponens and predicate logic, and it was clear it wasn't going to scale. And this kind of puzzled me. It wasn't going to scale. Like you can't use this on all problems, like scaling philosophical problems. That was weird. That phrase. Um, so then he was also interested in Principia Mathematica, and he said that Newell and Simon came along, proved most of the theorems in Principia Mathematica using a computer. And so they'd managed to represent that information in a computer, manipulate it in a way that was very promising. So I caught the bug and thought, this looks like a way to represent knowledge. So he went from philosophy to computer programming because it was a way to encode the knowledge he was interested in. It just seemed like a pretty funny jump to me.
Where have I heard that story before?
Yeah, I don't know. He was the first person at Cal to earn a PhD in computer science, interestingly enough, in 1969.
Yeah, I read that. I was kind of surprised by that, but I guess 1969 was pretty early. Uh,
Mm-hmm, mm-hmm,
but yeah, so he got all of his degrees at Cal. I think it was pretty clear that he was already sort of going to be heading into this career of kind of a combination of practical and theoretical computer science.
mm-hmm,
I think he did some stuff after Cal, kind of as a researcher and a professor and a lecturer, but in 1974 or early 1970s, he ended up at IBM, and this is IBM in San Jose. And in particular, actually, I'd heard a story about how he started working for IBM, but they put him in the Thomas Watson research facility, which is in like upstate New York.
mm-hmm.
And the story goes that he said, I don't want to work here, and so he quit and went to the research lab in San Jose and said, "Hey, you give me a job here?" I don't know if it's true or not, but it sounds like it fits his personality well.
He's like a California guy through and through, seems like.
Yeah, yeah, very much. And so he ended up at IBM in San Jose, and particularly ended up in what is now called the System R team.
Mm-hmm,
And I think this is where his database work really starts, because System R was an attempt at IBM to build a practical working relational database,
mm-hmm, mm-hmm.
and the team was led by Yocad, the relational database guy. His work there, uh, it was part of a team. He wasn't doing these things totally in isolation. And in fact, the first paper that we'll talk about, he's not the primary author on, but I think he was very deeply involved in building this first relational database, and in
Mm-hmm.
particular, sort of formalizing the idea of database transactions.
In an interview I saw with him, he said that this work was really controversial, which was pretty surprising. You look at something like SQL, like the ANSI standard of SQL, and you think about the sequent calculus, and it's hard to imagine, or even you wouldn't look at that because it's so ubiquitous and think, oh, this was highly controversial at the time. But he said that in the 70s at IBM, it was really controversial what they were working on. They had these kind of two camps. There was the COBOL EDP camp, which is more data, which is more network oriented. And then within IBM, they had this, he called it hierarchical. I didn't quite understand IMS in IBM. And that was really procedural. And so he said that the people who were talking about relational, like talking about set theory with databases, were way off in left field. And they were looking at these two arguing camps and saying, you guys are crazy. This way of going through data is highly procedural. The data, you don't get this data independence. So it's really hard to write programs. You should be programming in set theory. And when he said this, everybody just started laughing, like, well, of course, that's what we do now. Like a database is just collections of sets, really. And he said it's so much simpler to express these problems you're trying to solve in set theory than in these languages that he had at the time, both to like manipulate and to express this information. And people said, oh, that might work, but it's way too inefficient. And he said at the time it was like they're talking about thousands or tens of thousands of records, and their disks were 10 megabytes. And he said in the end, it turned out that Cod, who you mentioned, Cod was totally right. This is the right way to do this using set theory. These other people who were having these pitched battles about what should be done, they just completely fell by the wayside.
Yeah, it's interesting though. You and I probably think of relational databases as being sort of well established for a very long time.
Mm-hmm.
But at this time, it was is a new idea, and even in the late '80s when I started working. So, for instance, I remember on one of my early job interviews, somebody asked me what the three types of databases were,
Oh,
and the
what's
answer
that?
the answer the answer they were looking for was network, hierarchical, and relational.
Yeah, so that's what he's.
And
What can you tell me a little bit about network hierarchical? What is that?
so, network and hierarchical are actually two different things. But there were these three types of databases that people had been working on, and I don't know super well the technology of the network database or the hierarchical database. And network here does not mean like um,
Distributed system.
communications network. It means the way that the entities in the database were
Mm-hmm.
related to each other.
Mm-hmm.
Um, and similarly with hierarchical databases, it's a description of how the entities in the database
Mm-hmm.
um, were connected to each other. And so the relational idea came after both of those, and was, as you said at the time in the early '70s when they were starting to build System R, people were still it was still kind of a controversial idea, and people
Mm-hmm.
thought,
Mm-hmm.
that's you're going in the wrong direction. So
Mm-hmm.
anyway, System R turned out to be this sort of legendary team that really built the foundations of relational databases, and kind of established that as the dominant technology for databases.
Hmm. It's so funny to look back and see this controversy with contemporary eyes. It's kind of like, oh, they were arguing about how many wheels you needed on the car at the time, because it's that's not to say that they were thinking naively. It's just so hard to understand that perspective after these questions have kind of been settled, you know?
It's also, so one of the things we'll get to here is that there are certain ideas that I just think of as being sort of canon, at this
Mm-hmm.
point in time, stuff that
Mm-hmm.
is so well established that we don't even really think about it having to have been developed. And some of the papers they were writing about around this time were on things like transactions. They're
Mm-hmm.
trying to
Mm-hmm.
define what transactions were.
Well,
Uh,
let's talk about that. So you sent me this paper, Eight Transaction Papers by Jim Gray. I loved this paper because it was like, here it is on a platter, these eight important papers, and every page or two, I'm going to describe one of the papers. I'm going to give you a high level overview of it. Sure, you can go and read it, but here's a pretty good dissection of the important papers in the field by this person. How often do you get this? So when we talk about some of these luminaries, I would love to have this type of survey paper for every single person. You just go, well, what did that person do? You go and look up this. Well, here's the eight papers that they did. It was just beautiful. And the way that the arguments within the papers were described, I found it pretty easy to follow. It's a great paper called Eight Transaction Papers by Jim Gray. So let's talk about those transaction papers a little bit, Mike.
well, the first one I think that comes up, and this is during the System R time. I don't think he was the primary author on it. The paper is called, somewhat confusingly, The Notions of Consistency and Predicate Locks in a
Yeah.
Database System. And this was published in '76, I think.
Mm-hmm.
Um,
Mm-hmm.
so you will notice that nowhere in the title does it say transaction.
Yeah. Yeah, and he to
uh,
introduce this when I saw him interviewed, he was saying that they were trying to figure out how to do requests in a database, but there's no right answer. They started thinking in terms of invariance. So they tried to come up with a theory or a set of rules that describe the concurrency that would be allowed. And this is sort of the genesis of where a lot of this research came out of.
So this paper, just like right off the bat, it starts talking about stuff that we now think of as being, very fundamental. It talks about consistency constraints, and it talks about transactions, and it talks about what they call predicate lock, talks about locks in general,
Mm-hmm.
and how those figure into having consistent transactions. But then it also talks about this idea of predicate locks.
Mm-hmm.
Um, so there's all sorts of just very fundamental stuff in here about the way transactions work and what you're trying to accomplish with transactions and how you accomplish getting consistency in transactions, and kind of mind blowing how much basic stuff there is in this one paper.
Mm-hmm. Is this the one with the share locks and the exclusive locks or write locks, S and X?
No, that's the next one.
Oh,
So
okay.
one of the key ideas they talk about here, because it's in the title, is what they call predicate locks.
Mm-hmm.
And I am somewhat embarrassed to admit I never really, if I'd heard this expression before, I did not realize it. And the idea is pretty straightforward. I think it is
Yeah.
what it sounds like.
Yeah. Exactly. Yeah.
So they give an example in the paper where they're talking about how, suppose you're you want to compute a sum over a number of records,
Mm-hmm.
and so you have a bunch of records in one table, and you want to compute a sum over some field in those records,
Mm-hmm.
but you want the sum to be consistent with the records in the other table. And so what that implies is that you don't want anybody to change those records while you're computing the sum.
Right.
And it also
Right.
implies that you don't want anybody to add or delete those records. And
Yeah. I
the
like
adding
that.
the adding part is particularly confusing because it brings up this idea of what he calls phantom
Fan-
records, or
the phantom problem. Yeah. The phantom rows. Right. Yeah. So like
yeah.
you query maybe all the households in the state of Maryland, and then you look in this other table to figure out how many people live in each household, and you're just summing them up maybe for a census or something like that. And oh, by the way, while you've queried all those households in Maryland, somebody went along and added a new one to the database. And so your result is not accurate in the end because you didn't know this one was going to get added. That's a phantom row.
Right. And so they introduce this idea of predicate locks, and the idea is that instead of trying to identify all of the rows that you want to lock, you create this predicate lock that says, I'm going to lock everything where the state is Maryland.
Mm-hmm.
Even even new, if somebody tries to create a new row,
Mm-hmm.
it's going to hit this lock and not be able to create that row until
Mm-hmm.
I am done with my transaction.
Mm-hmm.
Um, so it's an interesting idea. It's a useful idea. But as we will talk about soon, it's an idea that's hard to implement
Mm-hmm.
because satisfying these predicates can get very tricky, and in fact,
Right.
it's potentially NP hard.
Pretty quickly, you're locking the entire database to do every single thing you might want to do, even just trying to select and sum up things, right? Just to read some things. This is a paper too where I think they talk about there you get a consistent concurrent execution of the transactions. This is the line as if they happened in serial. And this later came to be called serializability. So it's like we're not trying to assert an order based on what you're doing. We're just trying to say there is an order. It looks as if one thing happened after another, even though you're concurrently doing stuff. And we use locks to sort of coerce these different transactions, although they're not using that word, into an order. We'll call that serializability. Did I get that right?
Yeah, and I think they actually do use the word transaction, but the basic idea here is that you have this series of actions on records in the database,
Mm-hmm.
and you want that series of actions to be consistent with another series of actions which might affect the same set of records. One way you can do that is just to enforce this idea of serializability. So you can say, while my set of actions, my transaction is running, nobody else can do anything to the database. And if you were to do that, then everything is serializable because it's literally serial.
Mm-hmm.
But the problem with that is that it completely defeats concurrency. And so, your database becomes very inefficient because everything that's trying to make a change to it has to wait until the previous thing
Mm.
completes. And what you really want is to allow, the highest level of concurrency you can, while still guaranteeing this idea of the transactions looking like they are serialized.
Yeah, I like the way you said that. The highest level of concurrency you can. It's a kind of thorny technical problem to imagine. I mean, it would be easy to be like, okay, one person at a time can use a database, but that's not concurrent. So we want you to concurrently be able to access all this data that's in the database. It's not an easy problem to solve.
Yeah, and they talk about this idea that I don't think I'd heard before, where they talk about a schedule. So one idea that you could have is that you could take all of the actions that happen in the transactions, and you could potentially put them into a schedule, which gives you a consistent behavior. But the problem with that, as they point out in the paper, is that it would be very difficult to figure out all of the state that each transaction is going to modify ahead of time, so that you
Mm,
can make this schedule.
mm,
So the way that they accomplish what they would need to accomplish is they introduce this idea of locking. So the the scheduling is kind of done dynamically by each transaction obtaining and holding locks for the duration of the actions that it needs to take, that they don't want to interfere.
Now, I don't think I'd ever heard the term predicate lock, but you said this actually appears in PostgreSQL. Is that right? I think you told me that.
Yeah, so I thought, okay, maybe this is an idea that came and went,
Or
and
got named something different.
yeah, it got named something different. So I did a search on it, and you will actually find this phrase predicate lock in the Postgres documentation, in the sections on transaction isolation.
Mm-hmm.
I don't think it means the same thing as they talk about in this paper. I think it actually means what we're going to be talking about next. So there was a subsequent paper came out, I think, maybe even this in the same year, where Gray and some other authors talked about what they called the multi granularity
Oh,
locks.
okay. So this was the share and exclusive, the S and X locks, right? An intention
Yeah,
lock.
and also particularly this idea of what they called intention
Mm-hmm.
locks.
So that
So
sort of gets closer to what I would have guessed. If you started telling me, oh, they came up with this idea of predicate locks, I would have said, is that like two-phase commit? And I think this paper is a lot more in that direction, right?
yeah, so the idea with this multi granularity thing and the intention locks is that, so they know it's going to be too expensive to do these literal predicate locks, but what they
Because you
can,
you have to lock the whole table a lot of the time, right? Nobody can
well,
insert a Maryland row in this table while I'm doing this transaction.
and it's computationally expensive just to compute the set of records that you would have to lock given the predicate lock.
Okay.
Uh, so this is kind of the solution they came up to for that. And the idea is sort of that you have this hierarchy of things. In the paper they talk about the database being the top level, and then there's I think what they call areas, and then there's files,
Files, yeah.
and then records in the files. And I
Hmm.
guess we can think of it also as maybe like the database and the
Pages.
tables and
Oh,
the
tables.
pages and
Pages.
tables, and then records and things like that.
Mm-hmm.
And
Mm-hmm.
so what they realized was that you can sort of, you might want an exclusive lock on a record in a particular table, but you can also put what they call an intention lock on the ancestors of that table, so
Mm-hmm.
that you can sort of signal to other transactions that, you know, hey, I might be locking some other things in this table, so just so you know.
Mm-hmm.
So it kind of gave them this ability to accomplish what they were trying to accomplish with predicate locks, but also in a way that was um, actually, you know, implementable.
Mm. It doesn't sound simple. I remember reading about this in the summary paper, and they had these 3 degrees of transactions. Did this make sense to you? It was like the 0th degree is you you grab a lock on a thing, and then you release it right before you commit back to the database. Or The first degree after that is you hold a read lock in addition to your write lock on a row, and then but it's like short, it doesn't last very long. And then the third degree is you hold this long duration read in addition to any other locks you might hold. And that last one was the only one that's serializable, and that's what we call two-phase commit. But it kind of confused me when thinking about how is this two-phase commit. Did this make sense to you? I think I'm
Yeah, so you're right on the last part that the degree three is that's the only place where you can guarantee serializability.
serializability. Well, I kind of like squinted,
Um,
like, okay, I guess I buy it that that's two-phase commit, but I was a little confused by the different degrees.
so there, this is confusing to me, and I hope I'm not getting it hopelessly wrong. But
Oh,
there's
I'm
actually
supposed to be the
two,
confused guy, and you're supposed to be the guy who knows the things, who answers the questions.
there's actually two concepts of two phase transactions in this series of papers.
Oh,
So in one of them, he talks about transactions having what he calls a growing phase and a shrinking phase.
oh man. So sometimes I'm like, I want to understand this concept. And then they're like, okay, let me introduce some completely new terminology and abstractions for you. And sometimes that works. And sometimes I'm like, what?
So I think the key idea here is that so a transaction is going through this series of actions,
Mhm,
which
mhm,
may modify data, and so there may be a case where a transaction needs to get an exclusive lock on a record and then modify that thing and then let
mhm,
the lock go.
mhm.
And what they talk about in one of these papers is to guarantee serializability, you have to have transactions which only have two phases, this shrinking growing phase and then shrinking phase. And the idea is that the transaction cannot get a lock, release the lock, and then get another lock. So if a transaction tries to obtain a second exclusive lock, then it defies this two phase aspect of transactions, and you can no longer guarantee that that transaction will be serializable.
Oh, you got to put everything you need on the table and then do your thing.
Yeah.
Table
Um,
metaphorically, like a physical table in the world, not a database table. Okay, that was a really bad metaphor.
there's more to it that he gets into in later papers that has to do with things like writing the write ahead log and stuff like that, and saving certain actions until just before you commit and things like that. But yeah, I
So,
think the idea that is important here is that if a transaction tries to get a lock more than one time, then you have kind of defeated this two phase aspect of the transaction, and you can no longer guarantee serializability.
the Wired article about him, they quoted Michael Stonebreaker, who is a professor at MIT, but Stonebreaker is the person who created PostgreSQL. So I think of when I hear Stonebreaker, I think PostgreSQL. And he was so while Jim Gray was at IBM, and there was a team at Berkeley, and they were trying to like build databases for a really small market. And Stonebreaker says that Jim was incredibly smart, very willing to help without getting credit. Most people considered business data processing to be beneath them as like a research project. Who would help Business of America cash checks? Stonebreaker said. No one foresaw how essential databases would become. This is also a really interesting thing about the time. Like we're talking mid to late 70s. Databases are ubiquitous now. Everybody uses them, but in research fields, they were just like, you want to help these businesses do their dumb whatever filing taxes? That's not interesting as a research project, right?
I guess in retrospect, surprising that this was considered to be a boring problem then.
It's yeah, especially with the papers that they're writing about and the thorny technical issues in there. In the Wired piece, they move on and talk about Larry Ellison, who at the time was working for a company called Ampex, which is data storage for the CIA, and the agency had this code name for their project, which was Oracle. And so in 1977, Ellison launched a startup called Software Development Labs, and he's using System R papers as his like foundational motivating ideas. And then he starts selling his database as this mini computer solution. And he's thinking that IBM is going to be like too big and too slow and sluggish. And so then Larry Ellison obviously becomes Larry Ellison. He buys an island in Hawaii someday, right? And then in that Wire article, it said this is a quote: "There was no love lost between Jim Gray and Larry Ellison. They hated each other." One of Gray's Microsoft colleagues says, but Gray was gracious in public, and he mellowed with the years. So um, he said in 2005, his life had been, quote, a researcher's dream. You have a lot of fun, you do something innovative, and people make billions of dollars off of it.
Yeah. I never met Larry Ellison, but I suspect the fact that Jim Gray did not like him is another virtue of Jim Gray.
I had the same response. I mean, yeah, everybody hates Larry Ellison. I mean, I have no personal knowledge here. I just know that people hate Larry Ellison, and here's Jim Gray also hating Larry Ellison and seeming like a cool guy. So it seems like, yeah, he really was a cool guy.
So after IBM, he moved to this company called Tandem, which was a computer maker, and they were a really big deal in the 1980s. I think they eventually got sold to Hewlett Packard or somebody, but I remember in the 1980s they were like, a really big thing. Their value proposition was that they made these computers that were extremely fault tolerant, and so they were like literally redundant. So they were designed for things like banks and ATM machines and stuff like that. And the idea was that if some hardware component failed, you literally had a second operating hardware system that it would fail over to. And so, unlike a normal computer, these were pretty reliable in terms of their ability to continue functioning even in the face of hardware failure.
That's pretty interesting. So if you are a bank and you're storing people's transactions on your servers, you don't want to lose that stuff. You don't want your system to crash. And distributed systems are still pretty hard. Oh, and by the way, you can't just put everything in S3, which has 10 nines of, once the data goes in there, you
Right.
got 10 nines chances of getting it back out.
Yeah. So I think, I think it probably had a pretty big influence on the sort of stuff that he was working on at that point in time.
But he didn't do databases stuff, I guess, when he went to Tandem. Is that right?
Well, I think he did database stuff in sort of a research mode. So a couple of papers that he wrote about transactions came out during this period while he was at Tandem.
Mm-hmm.
But I think, if you read those papers, you will see that they talk a lot about fault tolerance and how you can guarantee that transactions, conclude successfully even in distributed systems and things like that.
It's funny because it's almost like his career is stepping through these modes of ACID, right? Of course, he was one of the people who came up with ACID. But I found this in the Microsoft interview with him in 2005. He said, when I left IBM, it was 1/3 of a million people. He said at IBM, the first line of code he shipped was shipped after he left the company. He joined that company, and 12 years later, he left, and then they shipped his code. He said 3 months after he was at Tandem, he shipped some code. And I really like this because it's like, this guy's super relatable, right? He wants to write programs and ship programs. And oh, by the way, I've got these database problems. I'll try to solve those too. He's like he seemed really cool.
Yeah, I got to see him give a talk at UCSD in the 90s, and it was a pretty good talk. But he seems like one of the guys, one of the people in this field that I probably would have just enjoyed hanging out with.
Mm-hmm.
He was also a hiker in addition to being a sailor, and apparently did like trips up into the Sierras and stuff. So in any case,
I was gonna say, was it the papers? So we had the 8 papers paper, and they didn't use the word transaction until these later papers. Is that? I think that's right. Am I remembering right? When they started using this transaction terminology?
I think he's talking about transactions even in the early papers, using that word, and then in the early 1980s, as he's working for Tandem, he writes two papers that were pretty influential. One is called a transaction model. It's really sort of an attempt by Gray to formalize this whole idea of transactions.
And that's where ACID comes from, right? Wasn't it there in that paper?
Well, I think he touches on the concepts, but I don't think he actually uses the words until the next paper.
Okay.
So the transaction model paper is sort of a pretty mathy paper. It invokes things like Hoare logic, and it talks in great detail about how transactions, how the commit process has to work on transactions. And I'm not sure, but I think it may be one of the first uses of the term write ahead log.
Oh, okay.
So he talks in that paper quite a bit about what you have to do to make sure that a transaction can be committed successfully. And he talks about how you have to, for every operation you do in the transaction, you have to put into a log an equivalent thing that will undo that thing. How that log has to be on some sort of stable storage, so that if one of the processors blows up or the disk blows up, you have some ability to roll that back when things restart.
Mm-hmm.
And so it's a very technical kind of mathy paper, but also introduces some ideas that we now also think of as being very basic.
Mm-hmm. The write ahead log is a pretty inspiring idea on its own too. And of course, I always think about that. How they when they write the Kafka paper, they're like, "Oh, we're just going to take this write ahead log thing and build a messaging system out of it, an event
Yeah,
system."
I'm not sure he knew how influential that was going to be, but
Exactly. Yeah. Another idea, which is like, "Oh, here's a little diamond, and you can build industries on top of it if you want to, and make billions of dollars in the future."
in subsequent years, I don't remember how long after it came out, but he wrote a follow-on paper to that called "The Transaction Model: Virtues and Limitations."
Oh, maybe that's the one I
And
was thinking of. Is that the acid one? It's not quite as mathy, right?
yeah, so he in that paper he uses the words consistency, atomicity, and durability.
Mm-hmm.
Explicitly writes those down and defines them. Um, and the only one that's missing there is isolation. Some other guys took these three things and added isolation and came up with the ACID acronym.
Mm-hmm.
Um, but yeah, Jim Gray kind of formalized at least three of the four aspects of acid.
There was something in one of the interviews where he said that the acid person who came up with acid really liked sour foods. um,
There's a couple ideas in these papers that are very interesting to me, but I don't think about them as much in the work that sort of work we do.
mm-hmm.
Um, One is he talks about parts of transactions that what's the word he uses? Can't remember the exact word, but it's things that once they've happened, they can't be undone. An example would be like maybe a cash machine. You know, once you've given the person their $20 bill, you can't roll that back.
Mm-hmm.
Um, so he talks about how that sort of thing has to be saved until the very you have to put those sorts of things into a separate log, and then right before you commit, you allow those things to happen so that they are delayed as long as possible into the transaction.
Mm-hmm.
The other thing that he talks about, which I don't really think of, is he talks in the second paper, especially, he talks about very long lived transactions.
That surprised me, right? You're talking like months long lived transactions.
Yeah, so I think of a transaction that's 2 seconds long as
Mm.
being
Very
potentially too
long. Yeah,
long,
exactly. I'm going to lock a
but
database for 30 seconds and things are going to start breaking.
yeah, but he talks about transactions. First introduces the idea of transactions as being kind of like contracts in law.
mm-hmm.
So
Mm-hmm.
getting married is kind of like a contract that you establish with your partner, and obtaining insurance is an example he uses as a long term thing where there may be some back and forth before you decide on what the terms of that insurance policy are, and so before it's officialized, it may take weeks or months to establish what the terms of it are. But anyway, those were those are kind of surprising things to me, but
Yeah.
you know, and I think they're kind of things that we don't really, especially the long term. The first part, the things that you can't roll back. It's still in place now. It's just not something that comes up in our work that often. But the second idea of having these like months long transactions, I think, have been largely supplanted by other mechanisms.
Hmm. So he went from Berkeley, where he's the first guy to ever get a PhD in computer science at UC Berkeley. He goes to IBM, works on System R, foundational in using set theory along with COD to to do databases, to build databases, to work on databases. Then he goes to Tandem in the 80s, and then in the 90s, he goes to Digital Equipment Corporation. Isn't it, this DEC was also one of those companies that people talk to as like they talk about as like an IBM, like it's a huge company, very influential, right? Am I right about that?
Yeah, at that time, digital was probably the second most prominent company in the hardware space. Their business was, IBM pretty much owned the mainframe space.
Mm-hmm.
There were competitors, but IBM was kind of synonymous with the big mainframe style of computers that people ran their businesses on.
Mm-hmm.
And then digital
Very
had come along,
expensive,
and
right? It's like only big
yeah,
companies would buy those because they're so expensive.
yeah, they were $1 million computers that took big staffs to run and maintain and so forth.
Mm-hmm.
And digital had come up with what they called the mini computer. Especially the PDP series were very popular in a lot of smaller businesses and scientific communities. Like, when I was an undergrad, a lot of labs had PDP 11s as part of their either control systems or doing simulations and that kind of thing. So they were addressing a different market, but it was probably the second biggest market in the hardware space at that time.
Mm-hmm. When I saw the interview with him at Microsoft in 2005, he said that they had a dual ladder. This is something people still kind of like we whinge about it a little bit in our industry. It's like, oh, I like writing programs. What's the career track for me? Do I have to become a manager? And he said at a deck they had a dual ladder, so they had a tech track and a management track, and they really respected technology, and they let the techies, this is what he said, influence and even steer the ship. And he said, unfortunately, the techies drove the company off a cliff, which is kind of like stab in the heart. Like, people on the software side, we have to think, we should be running this thing. We should be making these decisions. They're always coming to us with these requests that are outlandish and don't make any sense. And we really would be able to do. We'd be able to drive this ship. And he said, no, it didn't really work there. He said that they started running benchmarks there to figure out how fast transactions were processing. He said at the time they called these stunts. And he had this really interesting comment where he said he called this the guru gap. He said gurus, people who are experts, they always know how to tweak knobs and levers to get great performance. But then they'd go to the product guys and they'd say, hey, we want the product to just be like this by default. So you don't have to be an expert to get incredible performance out of it. And I really like that because his database research work, highly theoretical, he's dealing with really thorny problems, and he just wants to make it as dumb as possible to use. Can we make it so you don't have to think about these things and it just works and it works efficiently? I really like that.
When I started working in the late 80s, the first place I worked had a cluster of VAX computers, or Vaxen as they were sometimes called. And that was also, that was the big digital product at the time.
Oh, okay. So
So
not just a PDP. I get these names
yeah,
confused. I've heard of PDP 11s, I've heard of VAX, but I get like it's all just sort of this soup of like, what was that again?
yeah, Vax is probably their key product at that point in time, and probably even when Gray was there. But I remember one of the interesting things about working with these computers is that even I, as a sort of lowly tech support person at the time, you'd come in and there was this entire shelf in my office space of these orange binders that were manuals for the fax computers.
Hmm.
And I don't know if this is what Gray means when he talks about the techies driving the company off a cliff, but this was something that they considered to be a virtue. The fact that they had this 6-foot shelf of manuals to be able to operate their computers
Is that like
was
just RTFM kind of thing? Like all the answers are there. You just got to read you got to man whatever the tool is, read the manual.
I think they got sort of supplanted slowly by Unix systems, and I think that this was one of the dilemmas was that Unix is people we sort of now think of Unix as being a little bit tricky for the end users, but
Mm.
by comparison to what you had to do on a VAX, it was very simple and
Oh,
intuitive. So
okay. That's kind of surprising to hear that contrast, actually. But also Microsoft, right? I mean, Jim Gray went to Microsoft in 1995, and there was a funny quote in the Wired article where they were talking about how he didn't want to move to Washington. He wants to stay in San Francisco. So Microsoft builds a research center in San Francisco so that he can work for them in San Francisco.
yeah,
And then he wins a Turing Award, 1998.
yeah. Just not long after he had started at Microsoft, he won the Turing Award. For all of these things that he is now known for, transactions and locking mechanisms and just basic database stuff, especially relational database stuff.
No, I didn't go too far into the later work of his at Microsoft, right? So he joins Microsoft in 1995. He actually disappears in 2007. I think we'll have to talk about the disappearance here at the end. But at Microsoft, in the interview that I saw with him in 2005, he's talking about how he got really interested in data mining. You don't hear that term much anymore, but vast amounts of data, how we're going to find information in there. It's not just a database problem now. He was talking about building, he didn't use the term, but he's talking about building directed acyclic graphs to build these data flows and get parallelism out of it.
Yeah.
That was pretty cool. He's talking about
He
SQL
also,
servers and Bigtable as data flow models. Go ahead.
yeah, I also wrote a paper in his early time at Microsoft. He wrote this paper called Data Cube, a relational aggregation operator generalizing group by crosstab and subtotals. So, basically after pioneering so many relational database ideas, he sort of casually invents OLAP.
Yeah. But he just
So,
does it because he's like, oh, we have problems. The problem is we want to query the database and we want to do it concurrently. Or, oh, I've got a lot of data and I want to be able to process it efficiently in parallel.
right.
He started doing all this stuff with what did they call it? Terra something. He started doing all this stuff with like satellite. Terra server starts doing.
Yeah. Yeah. Terra server, as I understand it, was kind of like, it was this early geographical information system, kind of like what we think of as Google Maps now.
Mm-hmm, mm-hmm,
And I think also at this time he got involved with astronomers.
mm-hmm.
So he did a lot of work, and he ended up building this thing called Sky Server, which was kind of a riff on Terra Server that was to help out the astronomers go through
Mm-hmm.
their sky survey data.
And he just did that because he wanted to help the research community, right? I mean, he just did that because he was like, oh, you guys have a lot of data and you don't know how to manage it and query it efficiently in order to perform your research work. We can help you. And it was just sort of like a good natured, like, let's make your job, let's make what you're trying to do easier so you could do more science. That's cool, right?
Yeah, I thought it was really cool that he got involved in this, just to solve a problem, and also because of the intellectual curiosity of figuring out what the astronomers were doing.
So he has this incredible career. He works as both a researcher, publishing papers, and as a programmer. And he thinks of himself as a programmer. And he influences people like the founder of Google. He writes papers that Larry Ellison uses to found Oracle. He actually was on the doctoral committee for Werner Vogel's, the CTO of Amazon. Werner Vogel's dissertation committee in Amsterdam.
He was influential on Stonebreaker too. As you mentioned, Stonebreaker was he was the Postgres guy, also the Ingress guy before Postgres. And I found a little tidbit when I was going through some of the biographical stuff that just after Gray left Digital, he did a fellowship back at Berkeley, and he was working on this piece. It said he was working on this project called Sequoia 2000, which kind of surprised me because I also worked on Sequoia 2000
What is that
when I
project?
was. So it was this project to sort of improve database technology to be able to use it in certain scientific realms. At least it was, if from my perspective. And the guy that I was working at the time did X-ray crystallography stuff, and we were trying to use Postgres to store protein sequence data.
Mm-hmm.
And I've told you this story. Maybe I mentioned it on the podcast, but I was using a very, very early version of Postgres. This was like 1992,
Oh,
something like
wow.
that.
Wow. Okay.
Um, and I was having trouble getting certain things to work, and I ended up getting into sort of an email argument with Michael Stonebreaker, having no idea who he was.
Do you think you were right? All these years later?
Probably not,
Probably
but
not.
it's just funny because you know I was like, this doesn't work, and he was like, yes, it does. You just need to do this, and I was like, I still can't get it to work, and blah blah blah. And I had no idea who it was. I thought he was just some random Berkeley programmer working on this thing, and then I find out later that he's like the originator of
He
Postgres. And
created the thing.
yeah,
Wow. That's
years
pretty
later, he
cool.
won the Turing Prize. So I feel bad about that now, in
People I've picked
retrospect.
fights with. We should have that show, Mike. People I've picked fights with. Luminaries I've picked fights with. Okay. So then Jim Gray in January 2007, he disappears. He has this incredible career. He wakes up, gets on his boat. It's a 40-foot sailboat in the marina in San Francisco Bay. He goes out on the ocean on a calm day, and he was planning to scatter the ashes of his mother who had died the fall before, just before that, in 2006, in fall 2006. He was going to scatter her ashes on the Farallon Islands, which are 20, 30 miles offshore, right? And
Yeah,
he just
yeah,
disappears.
and he goes out solo. There's a bit about his wife at the was in like North Dakota or something. She was on a trip that she did on an annual basis, and so he had sent her a message saying that he was going to sail out to the Farallon Islands, and he let her know when he was back, and he was never heard from again. And
Yeah.
there's a there's a pretty long article in Wired about the search that they undertook. They were
Hmm.
looking for debris from his boat or
Right. Yeah. Apparently,
signals that they could.
yeah.
And
Apparently,
he had
when a boat sinks, a sailboat sinks, there'll be all kinds of just crap floating in the water. There'll be oil slicks in the water.
right.
It sort of breaks up, and there's stuff floating there. But they say he just vanished. The Coast Guard received no Mayday call. This is from the Wired piece. And Gray's EPIRB, an emergency radio beacon designed to broadcast a homing signal if it sinks, stayed silent. No sailors in the area reported seeing the boat adrift, and not a single life vest, flashlight, or scrap of debris belonging to the sailboat washed up on local beaches. Just vanishes.
Yeah, and they take advantage of his position as a sort of luminary in the tech field to hook up with these people who have access to satellite data and
Hmm. Hmm.
signal data and stuff. And so it's kind of an unprecedented level of search for somebody who went missing like this. Much beyond what the Coast Guard would normally be able to do,
Yeah, they were going to
and they
call.
still just found no trace.
Yeah, they were going to call off the search. They quoted it in the Wired article. They quoted a guy named David Swatlin, who at the time was a deputy commander of the Coast Guard sector nearby on the West Coast. And so 3 days after he disappears, Coast Guard holds a press conference, and David Swatlin says, "We've searched 40,000 square miles of ocean. We cannot search indefinitely. It's always a hard decision when to break it off." So they're like, "We're going to break it off after it's been a week." And then his friends in the industry organize, and they catalyze this massive effort. They're looking through satellite data. Bill Gates is like, "Here, use my jet." Microsoft donates a ton of money to the search effort. Werner Vogel starts using Mechanical Turk to have people visually inspecting satellite imagery from that period in time to look for telltale signs of his boat. And the Wired article is mostly from the perspective of, oh, it's 2007, and we're looking for this luminary in the field. And he's got all these friends who became leaders of tech companies we all know now, and they couldn't find him.
It's mysterious, I guess. Is There's really no better word for it. There was speculation that maybe he intentionally scuttled his boat because he was depressed and he was 63 years old, but he was in good health and seemed
Mm-hmm.
to have he was successful and
Mm-hmm.
happy, and so people kind of rejected that idea.
Yeah, all of his friends said there's no way, and his wife said there's no way. We were happy.
I personally have this hope that he sort of like sailed off to some secret island where he's building, models of pterodactyls and doing
That's
math
a
in a
War
notebook or
Games,
something.
War Games reference.
Yeah.
But the mystery on its own is kind of interesting. It's like in the Wire piece, they're like, look, this is one of the most technologically like vibrant places in the world at this time. In 2007, they have like cell phone towers, his cell phone's pinging as he's sailing away, and so they know the last timestamp that his cell phone pinged. Maybe there's these are really active shipping lanes. So maybe his boat got hit by a container ship. They're talking about how his boat could sink in like 30 seconds. Maybe he hit a whale, boat sank quickly. It's it's a sad story, but at the same time, and it's a mystery. You look back on the incredible legacy of work he left behind, and it's hard not for my position to look at his work and think like, wow, there's so much of what I do in my day job that exists because of the foundational work this person contributed.
Yeah, exactly. I mean, most of the people that we've talked about in this series of episodes have been people who, have contributed things to stuff that we use, compiler optimizers and distributed systems and so forth. But there's probably nobody, maybe in the whole history of the Turing Awards, who contributed so much that is so widely practically used
Mm-hmm.
up until this day and probably well into the future.
And the guy seems so relatable. So to have it end in this sad mystery, it's a bitter. It's a tragic ending. I think.
It's sad, and there are probably certain people listening to this who will think, "Oh, well, he was 63, he lived a long life." But for somebody my age, that seems pretty darn young. And there was, he was obviously healthy and fit, and could have continued to sail and hike and do interesting work. So it's sad that he disappeared then, but it's also kind of an intriguing story.
Yeah. Well, I was stoked to read about his life and to learn more about the research and to sort of understand a little bit more about the origin story of these ideas in databases, transactions, two-phase commit, ACID. It's cool to see the stuff coalescing at the beginning and to go, oh, that was controversial at the beginning, and oh, this is where those ideas emerged and then became foundational to the work we're doing. It changes my relationship to these tools today. It's a pretty cool thing to look back and see.
The transaction concept, especially, it's just hard now to imagine a time where people were unsure if that was the right way to go. I suppose there's still probably research and argument about other ways to do these things, but it just seems like such a basic part of computer science at this time that it's hard to imagine the point in history when that was still speculative.
Mm-hmm.
It's just interesting work to survey, because it's so basic and so important to what we still do that it's, I think, a good place to start in terms of what databases do.
Oh, cool. So soon we'll start talking about all kinds of crazy databases on this show. You heard it here first. Okay. If you'd like to reach us, you can email us at podcast@picturemecoding.com. You can also reach out to us on Blue Sky. Picture Me Coding is our Blue Sky handle. And we also have a Patreon support network. We have a handful of people supporting our work on Patreon. We do not run ads on this show, but we do appreciate support. For $4 a month, you can help us produce this show and pay for hosting fees and other things. This has been Picture Me Coding with Eric Aker and Mike Mole. Thanks so much for listening.
See you next time.
Bye bye.